be building a spreadsheet with demographic stochasticity. Jed talked to you about how population change is governed by vital rates, such as the birth rate or the death rate. And when a population size is large, we can use these rates and estimate the dynamics through time. No worries. However, when the population size is small, random chance can lead to deviation from these rates, and it's just due to the luck of the draw. And as a result, the populations can, just by chance, experience a lower birth rate or a lower survival rate, and this could be very bad, especially for rare or endangered species whose populations are small to begin with. This random variation is the realm of demographic stochasticity, and Jed defined it as the average variation in survivorship and reproduction in a population. And the key word there is variation, and it arises because although a population has a rate, like a per capita birth and death rate, the individuals that make up the population have an integer number of offspring, and they either live or die. And you'll see that because of this, small populations show more variation in the numbers of individuals that reproduce and survive, even though the rates, the average rates, may be constant. And it's confusing to talk about, so the best thing to do is just to start building a spreadsheet, and hopefully as we build the spreadsheet it'll become more clear. We're going to be building the female panda model, and Jed mentioned that the survivorship rate, and this is the probability of survival from 1 year to the next, was 0.6, and the per capita birth rate was 0.4. Now, if we have an annual survivorship of 0.6, then that means that 1 minus this value is the annual mortality rate. This per capita birth rate for a panda means that, on average, for females that are of reproductive age, they are able to reproduce, and if there are 10 females, we would expect that 4 of them would reproduce 1 offspring. And we've made this assumption for this particular spreadsheet. So if an individual reproduces, the panda will produce 1 offspring. Now it's true that sometimes pandas do produce 2 offspring, but usually one of those offspring ends up dying, and so we'll carry on with the assumption that if they reproduce, they produce 1. The spreadsheet is set up so that we can enter our population size in cell C5, and this can be any number between, say, 1 and 200. So we're going to be comparing 2 populations, one that has a population size of 10 individuals, and then we'll run a simulation where the population size is 25 individuals. Now, how are things set up? Well, down column A, we've established a row of 200 individuals. So this stretches all the way down to the number 200. And what we're going to do for this video is we're going to focus on the survivorship portion of the population dynamics. The overall survival rate is 0.6, so that means that we expect that 60% of the animals in our population will survive from year t to year t plus 1. So if our population size is 10, then we would expect 6 individuals to survive to the next year. Now, instead of writing that as an equation like we did in the population growth exercise, here we're going to simulate the fates of individuals. So we're going to let each individual either survive or die, and then we're going to consider just 10 individuals, and we'll count how many total survivors there were through a simulation process. Now, simulation often includes random numbers, and this exercise will be no different. We're going to start by entering a random number for each and every individual down column B. And remember, in Excel, that formula is just RAND, open parentheses, close parentheses. And we can copy that through, and now each individual has a random number assigned to it. If we press F9, we generate a new set of random numbers. Now we're going to use these random numbers and compare them to the survival rate in cell C2. We want 60% of our individuals to survive. And so what we'll have the spreadsheet do is evaluate the random number for a particular individual and compare it to this rate, 0.6. Any random number that is less than or equal to 0.6 will result in the individual surviving, and random numbers greater than 0.6 will result in a death of that individual. And we'll use an if function to do this. So we'll find the if function, and the logical test is going to compare the random number for individual 1 and ask, is it less than or equal to the reference in cell C2, our annual survivor rate? We'll anchor that reference. If it's true, we'll have the spreadsheet return the number 1, meaning the individual survived, and if it's false, we'll have the spreadsheet return a 0, indicating that the individual has died. So when we use this formula and pull it through, what we should see is about 60% of our individuals will survive and about 40% will die. And that's because we've set the equations up linked to cell C2. Now, down column D, we're simply going to tally the survivors. And we'll enter an equation that might look a little strange, but we're just going to sum cell C17 through C17, and we'll anchor the reference to the first C17. So we'll put $signs on that reference and then carry this through. And what this equation is doing is just providing a cumulative sum. So we start with individual 1. This individual survived, so we have 1 survivor. We now think about individual 2. This individual died, so we're still left with 1 survivor. Now we look at individual 3. They survived, so now we have 2 out of 3 survivors. And our population size is going to reference the individuals that are in this grid. So if I change this to 5, that means I'm interested in a population size of 5, which would include these individuals, and from the way our spreadsheet is set up, we can see that there were 3 total survivors. Individuals 1, 2, and 4 survived, while individual 3 and 5 died, and our result is that we have 3 total survivors. We need to enter an equation in cell C8 that will roughly do that exact thing. We need to look up the number 5 in this column here, and then we need the spreadsheet to return the value that is down column D, the tally of the survivors. And the function to do that is called the VLOOKUP function. V stands for vertical. So the first argument is the lookup value, and we're going to look up our population size. And V, vertical, requires that this number is stored in the first column of a table. And our table is going to be this table here, from cells A17 through the 200 individuals. Once we find the number 5, we want Excel to return the first, second, third, fourth column, the entry there, and you can see that Excel is returning the number 3 here. So it's finding the number 5 and it's returning the number 3. And under range lookup, we'll enter the word false because we want Excel to find an exact match. If we press F9, we get a new simulation, and we should be able to check to see if this function is working properly. So we find our population size of 5, and for that trial we ended up with 4 survivors, and they are recorded right there. The number of deaths is simply going to be the population size minus the number of survivors. Let's look at the variation in our trials here. So if I press F9, I'm getting new results. And the goal behind simulation modeling is to run a very large number of trials, enough so that we can really capture what is the variation in the number of survivors as we go through different simulations. So we're going to set up 100 trials here, and we'll just start our series and pull that down to the number 100. Now, if you'd like to do more than 100, you're certainly welcome to. I just want to keep this short for the sake of this video. The idea here is we want to press F9 to get a new simulation. We'll copy this number of survivors here, and we'll store it down column F. And this is the case where the population size is set to be 10. So I need to change my reference in cell C5 and set that to 10. So here's trial 1, 5 survivors. I would want to place that result here. I press F9 and I get a new result, and I want to place that for trial 2. In trial 3, I would place the number 8. And one thing that computers are very good at is doing this repetitive kind of work for us. And we can do that in a spreadsheet by using a macro. Now, the macro can be found on the View tab up in the ribbon. And you can head over to the macro button and then choose Record Macro. And we're going to call this trial for the population size of 10. So I'll write trial 10 and then click OK. Now at this point, Excel is recording every single keystroke that I make, and I can tell that the spreadsheet is recording because this little black button is there. When I press it, we'll stop our recording. So the first thing we're going to do is to press F9 and generate a new random number and a new tally of survivors for a population size of 10. So for this example, I ended up with 9 survivors. I want to click on this cell and then copy it. So I've copied this particular number, and now it's stored in Excel's memory. Then I'm going to come over to cell F16, and I want to find the next blank cell and then paste that result in. So we'll do that by heading over to the Find button. When the dialog box pops up, we'll ask Excel to find the next blank. So we'll keep this blank, and we want to make sure that we're searching by columns, and we choose Find Next and then Close. So you can see that Excel dropped down to the next blank cell. And then we just paste the values in, and you should see that number 9 appear. Now you might have noticed that Excel went ahead and generated some new random numbers in this process, and that's okay. We pressed F9, we got a simulation result. It happened to be the number 9. We copied it and we stored it here, and that's what's critical. Now at this point, we can stop the recording, and now I have a macro that will repeat this process and fill in the numbers for the population size of 10 for all 100 trials. Now I've added a text box here, and if I right-click on this text box, I can assign the macro trial 10 to it and then click OK. Then when I press this button, a new trial is run, and I can just click this 100 times, and I will be recording my simulation results across these 100 trials. There is a faster way for those of you who are interested. You can actually get into the Visual Basic code by choosing View, Macros, View Macros, and then find your macro and edit it. And what this opens up is the Visual Basic editor. So this is the code, it's Visual Basic. It's the code that Excel wrote, quote unquote, as we made our different mouse clicks. So the first thing we did was we pressed F9 and we generated new random numbers. Then we went to cell C8, which stored the number of survivors for that particular trial, and we copied it. Then we went to cell F16 and we found the next blank cell and we activated it. And then we pasted in our number of survivors. We pasted the values in, and then the subroutine ended. So this is the code that was generated by Excel. And this is Visual Basic. You can add a lot of code here by just typing in to this Visual Basic editor. What we're going to do is to use a for loop, F-O-R, and we're going to create a new variable called counter. And we could have called this anything. We could have called it I, but we're going to call it counter. So for counter equals 1 to 100. And what that does is when Excel hits this code, it's going to hit this code and it's going to begin a loop. And it's going to create a new variable called counter, and it's going to set it to 1. And then it's going to execute this code, and when it gets to the end of the code, it's going to hit the word next. So you need to add the word next in. So these are the 2 lines of code you add. If the counter is not reached 100, then it'll loop back up. Counter will turn to 2, and then it will execute this code, and we'll keep looping through until 100 is hit, at which time the subroutine will be exited and your macro will stop running. Now we can close out of here, and now with the addition of those simple lines of code, if we press our macro, we can now have Excel run our 100 trials for us very quickly. Put the video on pause, and I'd like for you to fill out and develop a macro that would run the trials when the population size is 25. So you'll need to change the input in C5 to 25 and then build your macro. I'll see you in a few minutes. Now I'm going to do the macro for the simulation with 25 individuals. We'll begin a new macro. We'll record this macro and we'll call it trial for 25 individuals. We'll begin by pressing F9 to calculate new random numbers. We'll copy the value in cell C8. We'll select cell G16, find the next blank cell, searching down the columns, close, and then we'll paste the values in. And then stop our recording, and now I'd like to add that loop in, so I'm going to go to the View tab, Macros, View Macros, Trial 25, Edit, and here we are. This is the code that was just recorded, and once again we're going to add the loop. For counter equals 1 to 100, and then add the word next right before the end sub command. And we can close out of here, and now we can run this macro and we'll have our results for the second simulation. And by the way, you can extend your number of trials much further if you'd like, and if you'd like to explore this more, you can also conduct more experiments with higher population sizes.